All right, let's talk about one of the most important decisions in all of system design. Seriously, it's a choice that quietly powers just about every single app and website you use every single day. The choice between building something to be stateless or stateful.
I mean, have you ever really thought about it? You're browsing, you toss something in your shopping cart, you get distracted, close the browser, and then hours later you come back and poof, it's still there. How does that happen? What's the magic behind that memory? Well, that's exactly what we're going to break down today. Okay, to make this super simple, let's think about it like this. A stateless interaction, that's a vending machine. You walk up, put your money in, press B4, and get your chips. The machine has no idea who you are or what you bought 5 minutes ago. Every single time, it's a fresh start. But a stateful interaction, now that's like having a really good waiter. They remember your name, they know you like your steak medium rare, and they keep a running tab of your entire meal. They have context.
So to really get this, we've got to be super clear on what we actually mean by this word state. It gets thrown around all the time in tech, so let's just nail down the definition.
At its core, state is just a server's memory. That's it. It's the information the server holds onto about what you've done in the past. Are you logged in right now? What's in your shopping cart? What level are you on in this game? If the server has to remember the answer to any of those questions, it is maintaining state. Let's start with the vending machine of the internet, the stateless world. This is kind of the default for a huge chunk of the modern web, and for some really, really good reasons. A stateless server, by design, has amnesia. It intentionally doesn't remember a thing about you from one request to the next. And what that means is that every single request you send has to be totally self-contained. It has to include all the information the server needs to do its job right then and there. And this approach has some massive advantages. Because no single server holds any special memory about you, your request can be sent to any server that's free. This makes scaling out a breeze. You just add more servers. It also makes the whole system incredibly resilient. If one server crashes, who cares? Your next request just gets routed to a healthy one and nothing is lost. This is so powerful that it's the very foundation of how the web works. The protocol, HTTP, is fundamentally stateless. And you see this pattern everywhere. Those REST APIs your phone's app is constantly calling, stateless. The content delivery networks that serve you images and videos at lightning speed, totally stateless. And the whole serverless movement, things like AWS Lambda, is completely built on this idea of small, independent, stateless functions. Okay, but sometimes you really do need that waiter who remembers your order. So let's flip the script and look at the other side of the coin, the stateful world, which powers a much more personal and continuous experience.
Unlike its forgetful cousin, a stateful server is all about memory. It is designed specifically to keep track of who you are and what you're doing. This session data is what lets you stay logged into your bank, or keeps those items in your cart, or shows your ongoing chat history.
And right there, that's the big trade-off. To get that rich, personalized feeling, the server has to hold on to your context. That means future requests depend on past ones, and that makes scaling way, way harder. A lot of the time, you have to ensure that all of your requests go back to the exact same server that's holding your memory. That's a technique called sticky sessions. The use cases here are pretty intuitive, right? Your online banking app absolutely must remember that you're logged in. An e-commerce site would be useless if it forgot your card every time you clicked. And can you even imagine a real-time chat app or a big multiplayer game where the server had no idea who you were from 1 second to the next? It would completely fall apart. So, we have these two models, stateless, simple, clean, scales like a dream, and stateful, complex, but enables those rich experiences we need. This brings us to the central battle. What on earth do you do when your stateful app becomes a massive hit? And that's a fair question, right? If stateless is the secret to scaling to millions of users, why bother with the headaches of stateful design at all? Well, like we just saw, some things are just impossible without it. You have to remember stuff sometimes. So the real question isn't if we use state, but how we manage it without everything grinding to a halt. Generally, there are two main ways to tackle this. The first and simpler way is called sticky sessions. You just tell your load balancer to always send a user back to the same server. Easy enough. But if that one server goes down, your session, your shopping cart, all of it is gone. The much more modern and robust approach is a distributed session store. Here, you take the state out of the application servers and put it in a separate shared database that all the servers can talk to, like Redis. Now, if a server fails, it's no big deal. The next request just goes to another server, which pulls your session from that shared store,
and you never even notice. And that idea of moving the state out is the key to how most modern large-scale systems are actually built. It's not about choosing one or the other. It's about being clever in combining them to get the benefits of both worlds.
So let's just put it all side by side. On one hand, Stateless gives you that incredible scalability and easy failure recovery, which is perfect for APIs and CDNs. On the other hand, Stateful gives you that memory you need for things like banking and gaming, but it comes with all that complexity. The real pro move is knowing which tool to use for which part of the job.
So let's put it all to the test with a classic system design interview question. You're in the hot seat and they say, design a chat system like WhatsApp for 1 billion users. Do you make your server stateful or stateless? It feels like a trap because a chat is obviously stateful, right?
And the expert level answer is, you use both. You split the problem up. You create a massive, horizontally scalable, stateless layer of servers for things that don't need a constant connection, like logging in or fetching your contact list. Then, you have a separate, specialized, stateful layer whose only job is to manage the live, persistent WebSocket connections for the real-time messaging.
And that really brings us home to the single biggest takeaway. The goal in modern system design is almost always this. Make your main application servers as stateless as you possibly can. Let them be simple and scalable. Then you take the state, all that precious memory, and you push it out to a dedicated, distributed storage layer that's built for the job, like a database or a cache like Redis. When you do that, you get the absolute best of both worlds, the massive scalability of a stateless architecture with the rock-solid persistence you need. And that is the choice that truly powers the internet today.